So to finish up this lesson, we're also going to graph y equals tangent of theta. And this is one of the quotient functions because we can think of tangent of theta as sine of theta over cosine of theta. And that's going to help us to use the unit circle because we know sine is y and cosine is x. So on the unit circle, tangent is y over x. So we'll label those points. And as I write these, just remember we learned this in the very first lesson, and these points are not something to memorize, right? This was stuff you can just figure out based on the fact that the unit circle has a radius of 1. So our 4 basic angles we do on trig graphs: 0, pi over 2, pi, 3 pi over 2, and 2 pi. So following tangent around, tangent is y divided by x. So here it's 0 divided by 1. We can have 0 in a numerator, that's fine. So this just equals 0. Moving over to pi over 2, we have 1 divided by 0. There we're dividing by 0, so that's undefined. Pi, 0 divided by -1 is still 0. 3 pi over 2, -1 over 0, y over x is undefined again. And then at 2 pi, we have that same value as we would up here at 0, so that's also 0. So when we come down to our graph, basically it's going to start out very similar, and this problem so far should feel pretty similar to graphing cosecant of theta. I'm going to skip and just do these values again. I'll skip the pi over 2's even though we know it's there. We'll label this y and theta. I should have done that in the last graph. Okay, so we're ready to start doing our points. Our next step is to draw in our asymptotes. So we have one at pi over 2 is undefined. 3 pi over 2 is undefined, and then it's going to continue in that same pattern. So basically this one at negative pi over 2, it's undefined. Remember, negative pi over 2 should always have the same value as 3 pi over 2 on any trig graph because they're on the same spot on the unit circle. And then negative 3 pi over 2. Graphing our points, we know we have 0, 0, and we have pi 0. So that means we're probably continuing the pattern, going to have negative pi 0, and then I also missed we have 2 pi, and so therefore we have negative 2 pi. So those we just kind of, right now it's just a bunch of dots on the x-axis. So starting to think about ASTC, we'll draw that in. We have to decide on each of these quadrant values which direction we're going to go in. So starting out in quadrant 1, which is here on my unit circle, here on my trig graph, everything is positive. So this piece of my graph right here has to go towards positive infinity as it heads towards that vertical asymptote. Going to quadrant 2, which is here, and on my graph it's here from pi over 2 to pi. Now we're in this quadrant, so tangent over here is negative because sine is the only thing that's positive. So this piece that's over here has to head down, okay, as we head towards the asymptote in that direction. Moving on to quadrant 3, here, which is here on my graph, which is here in my little picture. Tangent is positive, so we're going to go in the positive direction, okay? And then our last quadrant, when we are in quadrant 4, quadrant 4 here, tangent is negative because only cosine is positive, so this one is going to head down. And I'm going to do these all back in blue so we can see it as one connected graph. So we said it's going to go down over here. So tangent has a different look to it. It basically has these like slashes that are going up. So we'll continue that pattern in the opposite direction. Remember, we're continuing a pattern and not necessarily making this symmetric to the y-axis. So here is your pattern, making sure I don't cross the asymptotes. We're going to go to the calculator now just to verify that the graph is correct. So I'm in my y equals, right? I had just graphed cosecant of x. I could graph sine over cosine, but I just have a tangent button, so that's easier for this one. Just graph the actual tangent of x. Making sure we're in radian mode, right? My window, I already have my negative 2 pi to 2 pi, and I'll leave this negative 3 to 3. My scale is pi over 2, so we're going to press graph. So here we see that shape of tangent, okay, and basically negative infinity to infinity, tangent would just continue doing these slashes in both directions. So I do want to note that there are other points we can find on these tangent cosecant graphs. Like any of these graphs, we could do pi over 4, really any value. We're just using these basic values to get the shape of the graph. So our first question is, what is the y-intercept of tangent theta? So we can tell that that's 0. Name one value that is not in the domain of tangent theta. So what's one value I can't use? So I could use pi over 2. So this is different than naming the domain. I'm just naming some value that's not in there, or what is one of the vertical asymptotes. What is the range of tangent theta? They're separate pieces, but each of those pieces goes all the way down to negative infinity and up to positive infinity with no breaks. So we have negative infinity to positive infinity. Name one interval over which tangent theta is decreasing. So we're going to have a tough time with this one, because if we work from left to right, tangent is always increasing. It increases, it starts over again, it increases again. So I'm just going to write none or no answer for that one. Lastly, we're not going to really worry about doing these transformations questions, but do be aware you can transform any of these graphs. Now your homework is a little different this time, basically because you're going to actually graph the secant graph and then the cotangent graph on your own, seeing if you can use those same concepts. So it's the same steps. You have the answer key you can check with, but see what you can do. See if you can get the graph, find the spots you have trouble with, and then compare back and forth.